Hello and welcome to the Uniform Circular Motion video tutorial. Here we're going to watch a quick video on hammer toss and investigate some of the basic properties of uniform circular motion. So we'll start by watching the video. Pretty fast video, it's 11 seconds. Found this on YouTube. And there's the hammer being spun in a circle. And watch it one more time because that was pretty quick. Uniform circular motion starts basically once she starts to spin, and she lets go. So I've drawn a picture of it here. So she's standing here at the center of the circle, which means that at any given moment she is pulling the hammer in towards the center of the circle. So I can actually make that an arrow. So that's her pulling the hammer in towards the center of the circle there. When the hammer is up here, she's pulling the hammer this way and this way. And I know when you watch the video it looks like the hammer is moving outward, or there's something pulling the hammer outward, but if you really watch carefully, let's see if I can get a good frame. Right when we start to spin, right there. It's a little blurry, but you can kind of see the hammer here. She's pulling this direction, so that's her pulling. You can tell because she's resisting the floor so that she can keep the pull going. So she's always pulling this hammer towards the center of the circle. So that's the direction of the force. There you go. So there's the direction of the force. There's a force being pulled in towards the center of the circle. So now let's look at the direction of the movement of the ball. So, whoops. So when the ball is right here, the ball is moving this way, and then here it's moving this way and this way. I know when she lets go of it, it appears that the ball will move outward, and we'll investigate that in a second. But while it's spinning in the circle, the ball, say at this moment, the ball is moving that way. So that's the direction of motion of the ball, or the velocity of the ball right there. So if we were to look at a different spot in the circle, say here, where the force would be that way, where I'm pulling the ball in, the velocity of the ball at that moment is right there. So the velocity is always tangent to the circle, or it's perpendicular to the force. So this will always make a 90-degree angle. That's the motion of velocity. So when the ball is released right here, let's see, which way does the ball go? Well, because the velocity of the ball at that moment is this way, if you were to get rid of the force, if she lets go, we've gotten rid of the force, then there'll be no forces other than gravity. But gravity is into the paper is the direction gravity is moving. There's no forces other than gravity acting on the ball, so the ball will just continue to move in this direction. So what's happening during the spin is that the ball is actually always trying to move out perpendicular to the circle, or tangent to the circle, and she's pulling the ball in. So the ball gets here, she pulls it in. The ball would have gone this way. Ball gets here, it would go this way, but she pulls it back in. It would go that way, but she pulls it back in. So if we watch the video, it looks like the ball hits the net about here, which means she should be releasing the ball about here, because the ball is going to head out tangent to the way she releases. So she starts letting go of the ball here, and so the ball travels in that direction. So the only thing really to look at now is to figure out which way the ball is accelerating. So around the circle this way, the direction of velocity is changing, so we do have acceleration. It's a little tricky to figure out which way the acceleration goes, but we can do it a number of ways, and we'll do it this way. So because force equals mass times acceleration, the force and the acceleration always have to be aligned with each other. This actually makes a lot of sense if you think about it. If you push a box across the floor, if the net force is to the right, the box will accelerate to the right. If the net force is to the left, the box accelerates to the left. So we just have to figure out which way the force is pulling, and that's the direction of acceleration. Well, the force is always in towards the center. So not only is this the direction of force, but it's also the acceleration. So the ball is always accelerating in towards the center of the circle. It is not accelerating out, tangent or outward or anything like that, in towards the center. So those are some of the basic properties of uniform circular motion. Thank you for watching the Uniform Circular Motion video tutorial.